Hey guys, so we are going to be learning about how scientists are going to classify matter, and we're really going to focus on how chemists classify matter. And a lot of this, I'm hoping, is going to be a little bit of a review. Teaching physical science, I know this is something we introduced you guys to. We might be throwing in some new language in there, a little bit more detail, but this just gives you kind of an overall general view of how we're going to be classifying matter from a chemistry point of view. So you're going to have to pause probably at different times as far as whatever it is you want to fill in here. But whenever we're classifying matter, we really look at the physical properties of that matter and then eventually the chemical properties. So there's two main types. Physical is this first, and physical properties are a property that can easily be observed without changing the matter. So I could observe real simple ones that aren't even on this list. I can observe its color, I could observe its texture, I could observe its taste, I could observe its state of matter, and I can do all those things and I'm not changing the matter as I do this. I'm not turning it into something new as I do that. Some ones that are a little bit more science-y like would be solubility, so how well does it dissolve into something else? Conductivity, so would it be something we'd want to use to conduct heat or conduct electricity? Malleability, remember that's bendability, so how workable is it, how malleable. We could observe something melting and actually collect data on its melting point. Same thing with boiling, and I'm not all of a sudden changing water just because I heated it up enough to go from a liquid to a gas. It's still the compound water. I'm not changing that. And then density would be another. I can measure the density of wood, of water, of mercury, and I'm not changing it into some other type of matter. So these are all physical properties would be one way we would look at it whenever we classify matter. Another thing that we would look at is its chemical properties. So chemical properties are things that whenever I do observe it, I have changed the actual type of matter that it is. So flammability, I cannot observe paper catching on fire without changing it into the carbon that it was made from, and oxygen being released and anything else that might be given off from that. So flammability, how it reacts. I can't watch iron rust without that reaction, or corrosion. If I really go to that one, I'm changing it into something else. We're going from iron to iron oxide. I cannot watch hydrochloric acid react with baking soda without seeing it truly change into another pure substance, changing into something else. So that's how we classify things. And we end up with this chart. Now yours is a little bit smaller than mine. And this is something that, again, I know that we talked about whenever we were in freshman science. So we just want to do a review. I have a couple of things out here that I'm going to go through just as a quick little reminder with some of these. But this gives you a stepping stone as we kind of dive into all these different categories of chemistry and we start to study them. So if we just, go in general, if we look at matter, and I'm not going to take time to define these, that's something that you can do on your own. But if we just start as our big category of matter, matter is broken down into two main groupings. And one of those is pure substances. And then if I were to combine those pure substances together, I would end up with mixtures. Okay, now we're going to be playing around with both sides of this diagram. Quite a bit first semester, we'll be messing with the pure substance side. But then as we go into second semester with acids and bases and solutions and things like that, we're going to be messing and playing around and investigating the mixture side of things. So if we look at pure substances, we can break those down into elements and then compounds. Okay, so we end up with these things, and I think on my next slide you have some examples that you can put in there. Yeah, so we end up with elements and compounds here. So elements, you need to think, periodic table, if I could get you to move, but I can't because I can't move my camera, but think of the periodic table that I have in the classroom. That's a periodic table of elements, and I brought in a few today. I don't know how well you're gonna be able to see these, but this is copper, so just absolutely gorgeous. We don't pull it out of the ground this beautiful, so we have to do quite a bit of work. We go from copper ore and we can turn it back into the element of copper. This is sulfur, which sulfur you actually could find in its pure state. A lot of times it combines as an S8, but it's still the element sulfur. It has a very unique rotten egg-like smell. My mother used to, she believed that this stuff would like cure almost anything, I swear. And there's these things in Texas, they're called chiggers, and they bite you like a mosquito, but you can't find them, they're so small. And I remember like she would make me try and like put sulfur on my ankles so I wouldn't get bit by chiggers. So, you know, sulfur is something that a lot of people like. They'll do very, very different things. There's springs that have natural sulfur in the springs, and some people think that it's healing and power. I think it just smells like rotten eggs. But this would be yeah, pure substance. What kind of pure substance? Well, sulfur. This is probably one of my most favorite examples that we have here at school. This is silver, and just look how beautiful that is. So just shiny. Now, if you can kind of see along the edges, it's beginning to tarnish. And once it tarnishes, we're creating a compound. We're creating a silver oxide that we would have to get rid of if you're at grandma's and she doesn't want her silverware to tarnish, right? But these are all pure elements. Compounds would be two or more elements that we have chemically bonded together, and they're very uniform in how they bond, very discrete in how that happens. This would be one example of that. So this is ammonium and chlorine combined together. So we have nitrogen in there. I don't know how I can see this. Hydrogen and then chlorine, and it makes, and everything I brought today is just going to be a white crystal, but it makes a white crystal. It has a very unique odor to it. If you know anything of how ammonia smells, I could already smell a little bit of that whenever I opened up the lid. This is sodium iodide, so just another type of compound, okay, just a crystal compound. Taking elements, combining them together chemically to make those. This is calcium chloride, okay, but very, very specific in how they're arranged. 1 calcium, 2 chlorines. So very specific arrangement, which would be very different whenever we're making mixtures. So compounds, fixed ratios as to how they're made and how they're chemically bonded together. And those would all be examples of compounds. So this first part of chemistry, we spend a lot of time really understanding elements, how they combine together to make compounds, how compounds and elements might react with each other to produce new compounds, and we really concentrate a lot on this part of the diagram. But we don't want you to forget, and we do spend time talking about mixtures. If I take 2 or more pure substances, combine them together, really in any ratio, I can end up making a mixture. So let's go back to that. If I were to take sodium iodide, and I'm going to take another pure substance, we'll pretend like this is pure. So pretend like this is distilled water, like what Miss Merkus talked about whenever she was talking about DI water versus tap water. So let's just bear with me, pretend for a moment that this is real plain old distilled water. Nothing else is in here, okay? It's a super clean beaker too. I'm gonna take 2 pure substances. Now I combine them together. Don't expect anything fancy. And as they begin to mix, I'm creating a mixture. And just the verb of that helps you understand what's happening. So if these stay together long enough, as long as the sodium iodide is soluble, able to dissolve in water, I'm creating a mixture. The ratio doesn't matter. So with mixtures, we do not care about what that ratio might be. Anything can be a mixture. So I could tell my 8-year-old, I want you to make me some lemonade, and she might take 1 lemon and 4 cups of sugar, add it to water, and she goes, here Mom, here's your lemonade. It might taste awful, but technically that's still lemonade, even though I wish you would have taken maybe like 8 lemons and just 1 cup of sugar, combine that in some water. Mixtures can have any type of ratio, and they're still a mixture. Pure substances need a specific one. Oh, did not know that was on there. Hold on. See, it's an empty room, and I didn't have any of you guys saying, Z, there's like something on your screen, you have to get rid of this. When we look at mixtures, we can break them down, and again, I'm not going to take time to handwrite in the definition. You can if you want. Didn't give you a lot of space, but these are things that we've reviewed already in physical science. So we can break these down into homogeneous mixtures and heterogeneous. Homogeneous are going to look the same throughout, so once we get everything to dissolve, this would look the same throughout. I could stir it, shake it, heat it to make it dissolve a little bit quicker. And heterogeneous is going to look different throughout. So I brought in a few examples of this. if we look at homogeneous mixtures, we have three different types here, okay? And they really differ on, minus the alloy. An alloy is really a unique solution because it's a metallic solution. It tends to be a solid at room temperature. But the biggest difference between, you know, a colloid, a solution, and even a coarse suspension is the size of the particles that are dissolving in that bigger solvent, okay? So like, you know, the size of the salt that's trying to dissolve or whatever it might be. So with this one here, a colloid, the one thing I brought is, well, we have a little bit of shaving cream. So I don't know how well you're gonna be able to see this. Oh, you guys can tell that I guess I don't use shaving cream on a daily basis. But that's actually a colloid, okay? And there's kind of a unique thing that happens with colloids. We'll see if this works. I'm gonna turn some lights out here. I might have to blink my screen for you to see this, but, oh, I gotta turn my backlights out. Hold on. Okay. And hopefully I don't trip as I do this. So sometimes with colloids, you can, and we'll see if it, yeah. So you can get a large portion, I don't know what you guys are all able to see there, but you can get a portion of that colloid to light up because it's reflecting all of the particles that are dispersed in there is reflecting off of that. Now we can also see this, and I didn't really even try this ahead of time, but let's see if I can do this with aerosols, because aerosols are also colloids, okay? So let's see what we can come up with here. Oh yeah, look at that. Are you guys, hopefully you're catching that. Hopefully I'm not like killing you. But we can see the laser beam, right? I'm hoping you guys get to see that. I don't know if you're gonna be able to or not. There we go. So colloids will disrupt. This is called the Tyndall effect. Oh my gosh, it smells horrible in here. This is all aerosol that I'm spraying, but would disperse that, okay? So colloids to me are just like super cool. All right, let me see if I can actually get some of this back and going. You might have to, you guys, I'm covered in shaving cream right now. There we go. Okay, so that was probably my messiest one. When we look at those colloids, whew, you could smell this room right now. Boy, it is just smelling ever so fragrant. Okay, solutions. Well, that's kind of, now look, you know, there's been some time that's gone by with this beaker. It's getting even, a little bit of time is already getting clearer and clearer that sodium iodide is actually dissolving into here. We're creating a solution, but quite frankly, almost everything we buy in a store is in the form of a solution. So I brought a few in here. How do I know this is a solution? Because it says hydrogen peroxide when I read it, but if I get more detail, it tells me that this is 3% hydrogen peroxide. What else is in here? Water. We've taken hydrogen peroxide, mixed it with another pure substance, water, made a solution. Lysol cleaner, this is like a hot commodity nowadays. If I start to read this, it also tells me percent breakdown. So 3 different chemicals before we ever get to water, a solution. Because if we were to look at this, I don't even want to waste it, but it's going to end up just being a clear solution. I think that's all the solutions that I brought in here. Yeah. So solutions, salt water, Kool-Aid, Gatorade, coffee, as long as it's actually strained and it's not cowboy coffee or something like that. Those would be examples of solutions. Acids and bases are solutions. Vinegar is a solution. We're going to be spending a decent amount of time talking about solutions. Colloids, we don't do too much with. Alloys, this is material science. That's why Ms. Marcus lets me do this section, because wow, I heard that's a really super cool class. You get to do really cool things. There's like a lab every day, and you learn about all kinds of crazy stuff. But alloys you won't find on the periodic table. Brass, steel, bronze would be there. It's a mixture of 2 or more elements combined together, okay? Many times metallic, and they're going to be a solid at room temperature. And then coarse suspensions are kind of fun too, because, you know, if you think like this is some very interesting vinaigrette dressing that for sure is not going to look the same throughout. Heterogeneous. Now, I could shake it, and for a while, maybe it's going to look the same, but over time, coarse suspensions will separate, they'll settle, go down to the bottom. Here's another one. This is Italian dressing. Again, you know, take a look at that. Definitely not the same throughout. If we shook it, it would look the same for a while, but over time, it's going to separate, okay, and fall out to the bottom. But so a mixture, 2 or more pure substances that are combined together in there to create that. Okay, so we just wanted to give you a reminder of how you would classify matter, what it would look like. And on your own, if you need more information with this, you're needing more of a reminder, go back and look at those definitions. What is an element? How do we define compounds? Homogeneous, heterogeneous. Refresh your mind with that, okay? And this is really our springboard as we kind of jump into the units that go ahead. All right, pay attention to what the homework assignment is, what you're supposed to do. So make sure you're reading that learning target, and then we'll see you in class next time. Take care.